go?
Yes, I'm ready.
Great, let's go to the next round.
Okay.
Please.
Yep. So I was just telling David earlier, it's really neat to hear about the nuances of everybody's work, but it's also especially exciting to see where the intersection of our different projects are, programs, and getting insights. So anyway, hopefully I get to add to that a little bit. So I do want to just talk. So my work is going to focus in row crops, and particularly in the Corn Belt. I think it has application in plenty of other places, but that's the data that we're drawing from. And we definitely have this. I think we saw it on a national level yesterday, the increases in temperature since 1890. What I like to present when I'm located in Illinois to local groups around there is this migrating Illinois map that shows, based on emission scenario and time, what our climate might feel like in Illinois by mid-century and end of century. And right now we're on track to have something like East Texas, and that gets people's minds when I think about it, especially corn growers. And it's, well, how's corn doing in East Texas? And no offense to Texas A&M Aggies, but you know, it's nowhere near
less than ideal.
Yep. And I do want to just touch a little bit on precipitation as well. For the Corn Belt, this is something where we're seeing a greater frequency of extreme rainfall events, where they're up 34% or so since the beginning of the 20th century. And we're seeing this more commonly. So overall, we're having greater precipitation, yes, particularly in the winter and spring, but also this trend of actually less precipitation in the summer. But these precipitation events can be very heavy rainfall events. So thinking of waterlogged conditions then with these flash droughts, and that provides some challenges for crop production. It's pretty well known in the weed science realm that weeds adapt to their environment, and including management. And this is facilitated through adaptation by natural selection. You know, weeds have, first of all, you know, every field has pretty significant seed bank there, and many species, and most of these species have pretty phenomenal genetic diversity. They have phenotypic plasticity, and a lot of them produce a lot of seeds. So there's opportunities for adaptation. And in fact, with some I'll talk a little bit about, Scott will follow up more after me, that really they're adapting quicker than our ways to manage them in some regards. And that's concerning. So I just want to set that stage before I get into too much into climate change here. So as we're thinking about this, what's some thoughts? Anybody have thoughts on what's a good example of adaptation by natural selection in weeds? Anybody have ideas of what's occurring? President Scott, you can't.
Herbicide resistance.
Herbicide resistance, absolutely. Herbicides are an essential component of weed management in our production agriculture in the Corn Belt and many other places of the world. There's been a number of different herbicide modes of action released over the last 80 years. And with nearly every single class of herbicides, there has been herbicide populations of weeds that develop resistance to it. And I don't want to steal Scott's thunder, so I'm not going to say a whole lot about this, but this is just a good example. It's a real obvious example of adaptation in weeds to management. Some would argue, and I would agree, that herbicide resistance in weed populations is no less of a threat to agriculture than antibiotic resistance is to human health, because of the importance of these tools in producing food on a large scale, and how quickly we're losing effectiveness to them. Okay, so I just want to set the stage of want to be framing several questions and and showing data that addresses those questions. I want to give you an idea the background for that data. So most herbicide evaluation program, most land-grant universities have a herbicide evaluation program. And these are projects usually ran by a faculty member that gets sponsored projects from herbicide companies that want to test out products, get third-party testing to share. And so the university will conduct this research, these trials, send the report back to the companies, and usually the data goes on the shelf. And some universities have over 100 trials per year. And these trials have been going, most of these programs have been going on for decades. And my colleague, Aaron Hager, and I were discussing a few years ago, like, there's probably some value in this data because these are actual experiments, field experiments over a large area of space and time that are really relatively untapped. So I have a couple postdocs, Chris Landau and Jamal Khan, who've been working on this data. We initially started just with the Illinois data set, and we've expanded now to 20 universities, including Ontario, Canada, just focused at this point on corn and soybean trials, although anytime I present this in another region, I almost, to weed scientists, I'm like, hey, we'll share our data on, you name the crop. And so I think there's a lot of opportunity for this type of approach to help maybe shed new insights with data that's already there that doesn't require, that can get a lot of environments. So we have 11,000 trials, basically 11,000 environments, and currently over 10 million observations. And the beauty is it's in a single database. It's a database we can also link with weather records, with soil records. You begin to think about how exciting this is if you like working with data. And most of my research is the manipulative field experiments, either field or lab based. So it's been really exciting to get into an area where we can frame completely different questions. So I want to first talk a little bit more about weedy adaptations. Simple solutions to difficult problems can sound great. It's easy. It's how you solve the problem. And glyphosate commercialization of glyphosate-resistant corn, cotton, soybean enabled the use of glyphosate, this broad-spectrum, non-selective herbicide to be used in crop. And this was adopted relatively quickly, and based in part on the way a lot of messaging came out with the launch of that. It actually there was a simplification of many of the weed management systems in the corn belt. And so, this was relatively rapid and widespread, replacing more integrated weed management systems with relying largely and sometimes solely on a post-emergence herbicide. So how'd that work out? Probably most of you are aware of how that worked out. But what I want to show you is we looked at the glyphosate efficacy trials, this large database, on what this publication was on 7 of the most important agronomic weed species. And what we saw over time for every species, when we looked at how glyphosate performed, it steadily decreased up to a loss of 33% per decade in effectiveness. And if we're thinking about adaptations, not just overall mean control, I was very interested, what is a variation in control? So here we're looking at CVs, coefficient of variation over time. And for every weed species we look at for most sites, there's a steady decline, steady increased variation in time to this product. It's important to tell you that none of the species we look at, none of the populations actually were deemed glyphosate resistant. Okay, in fact, 2 of the species of this, there is no common land squirters and doubly have no documented glyphosate resistance anywhere in the world, but they follow the same pattern. So however we're measuring resistance fails to capture some of the adaptations that are going on, even to some of the most, very effective types of products that are used. And I think it was already mentioned before, glyphosate is the most widely used herbicide in the world. So and it adds to the significance of it. Um, and so with just glyphosate alone, over 300 populations, cases of documented resistance in 50 some species. And, it's just one herbicide, but again, that's the real obvious way to detect an adaptation. I think there's a lot of benefit to thinking about the other types of adaptations that are not necessarily directly related to how a herbicide interacts with the plant. Some of these life history traits that favor the ability of weeds to adapt to not only management, but also to climate change. I think Lou Ziska presented 8 years ago with this group. I had the chance to look at his slides and made a really good case that, actually the weeds are adapting very quickly, and there may be some benefit to understanding their adaptations better. And why? Well, I think the whole glyphosate story, part of this, I want to share with you is that that system that was launched was pretty darn effective when it first came out, but how it was stewarded reduced the shelf life, the usefulness of it. I think glyphosate still works to some extent, but it's a shell of its former self, and we're beyond the point of no return. It's just not effective in a lot of cases anymore. So we want to learn from the past. So we will have new technologies, I trust. The industry is working on it. Probably maybe a few new herbicides, probably a lot of other non-chemical types of tactics. And I'm not here to show the list of what may be, what is commercially available or is coming down the road. My argument is we need all of it, and we need to use it in a diverse way and try to prolong the shelf life of these tools, because we have a moving target we're dealing with. Okay, so transitioning to climate change. So I mentioned before about precipitation, temperature. These are very important factors that influence how some of our weed management tactics work, including pre-emergence herbicides or herbicides that are soil active. And then there's plenty of the manipulative research that's quantified in a lab setting how soil moisture affects, the product on a weed. But we decided to use this large data set to find out, well, if we look at a variation, the wide variation of rainfall and temperature scenarios, which we receive currently in the Corn Belt, how that influences efficacy. So here we're looking at water hemp response to atrazine and S-metolachlor as it relates to average soil temperature over a 15-day period on the y-axis and total rainfall over that period on the x-axis. And this is a contour plot, so the darker the color, the higher the probability of successfully controlling water hemp with that product. And as you get to lighter colors, that's where control begins to fail and fails completely. And so what we saw, this is one example. Here you see an example, there's about a 55 centimeter rainfall threshold to that herbicide work accordingly. This makes biological sense. The herbicide has to be in soil water solution for the plant to take it up. So there's a mechanistic basis for that. But what we saw was that, and not everything followed this exact pattern, but what we saw, often when we get to these extreme kinds of conditions over this window of period of time, efficacy falls off, it declines. There's a weakness, we have the kinds of weather variability in the Corn Belt that don't always favor these things working ideally. And in this case, we're able to quantify it. And just another, this is actually looking at how atrazine alone performs relative to atrazine combined with other soil active herbicides. It's an odds ratio. So there's the dotted vertical or dashed vertical line there is at 1. So any of these combinations that are greater than 1 means that there's a greater odds that it'll work better than atrazine alone, which makes a lot of sense. So there's a benefit of having multiple pre-emergence herbicides out there. That being said, looking at the relationships, it doesn't remove the risk of having extreme types of weather during these very important time periods of the crop growth cycle. Well, what about post-emergence herbicides? Okay, we'll go for the low-hanging fruit on this project. because there's a lot of post herbicides that are used. They're important. Here I'm throwing you a whole bunch of contour plots. The different columns are different herbicides, and the different rows are species or weed species group here. And in this case, our analysis looked at precipitation and air temperature before, during, and after post-application. It turns out after post-application was the most predictive model. And what we see is that, again, when we get to some, there are regions where when you get some of the extreme types of, something that's not in the average, but at the extreme, things begin to fall apart. Also want to draw your attention, if you look at any one column, say if we just have these 3 weeds in our field, you look in one column, there's plenty of kinds of conditions where at least one of those species is going to escape control, and argues for, obviously for an integrated system, but also as we think about the weather changing in the Corn Belt, what implication of the weather change, the change we're expected to have, how might these work in the future if we don't even account for adaptations or resistance? Regardless of the type of tactic to use, it would be nice to know how this impacts crop yield. So we did some work looking, this is actually work we just did with the Illinois data, but we're currently working on it for the entire data set, but looking at relationships between using weather records, herbicide efficacy records, not looking at herbicide, but the percent weed control we get from whatever the system was, how that related to crop yield using some machine learning approaches. And what the major predictive links that came together were that yield loss due to weeds is exacerbated by either these high temperatures or low rainfall during corn silking or soybean flowering. So it's kind of later in the growing season as this plant's transitioning from vegetative to reproductive. When you have less than ideal control, I'm talking less than 95% control, which is hard to achieve these days, that adverse weather exacerbates yield losses that we'll see. And this is exactly the kinds of conditions we're expected to have in the Midwest, later season, drier, hotter conditions for the crop. And so it really challenges, okay, let's just throw in the fact that some of these conditions are making the products work less effectively. We have herbicide resistance. It really speaks to the urgency we need to how we're going to adapt our crop production systems to avoid significant yield losses. So here's the situation. This first point, weeds are poised to adapt to climate change at a faster rate than our crops. That was Lou's take home from last time, and I just don't have time to go into that, but I think he makes a pretty good case for that. Herbicide resistance is on the rise. I don't know if metabolic resistance is particularly scary because the weed doesn't even have to be exposed to the herbicide to be resistant to it, because it has the metabolic machinery geared up from exposure to other chemistry that can help it overcome response to the herbicide. Even without what we're classifying as herbicide resistance, even without that, weeds are adapting. And I think this is something we, in some ways, it's probably a good thing. If we think the bigger picture, that we have plants out there that can adapt, and perhaps I feel like this is one of our biggest gaps, are knowing what are these weedy adaptations, not only to have better understanding of how we might change our weed management systems, but also how they might be useful in crops. So there's some types of biotic or abiotic resistance mechanisms, stress tolerance mechanisms might be useful in crops as well. The current trends we have right now in weather variability in Corn Belt, we have this very large data that shows that threatens the efficacy of some of our most important herbicides that are being used today, and it also exacerbates crop losses due to weeds. So, if anything, I hope you take from this is that whether just for crop production in general, we need to continually be developing new types of management strategies and well, or and do a better job of stewarding them as well. And so let's just say with this day, we're like, what if we just innovation, we kind of rested on our laurels for a while. Like, yeah, there's maybe companies just don't have a lot of benefit of market share to develop something new at this moment, or we're gonna ride out the dicamba tolerant whatever for a little bit longer. What's the cost of that faltering innovation? And I realized we could actually quantify that with this data set. Here, just looking at corn yield trials, nearly 1,500 environments, looking at yield loss due to weeds as a function of what the overall season-long average weed control is. There'll be multiple species and multiple times that usually data are taken, but if we just pull an average together to see, okay, whatever approach that was, here's the level weed control with obviously 100% being dead weed, and then how does that relate to how does that impact yield? This it's actually varies a little bit across our different locations, but then we can begin to use some scenarios where we can run some scenarios of, all right, what if we lose 10% weed control over the next time period? We define our time period, I don't know, decade or whatever we want it to be. Or what if we lost more, if there's like the steady adaptations going on and just we're not coming up with something new or better systems that slow erosion of our effectiveness of a weed management system. What does that cost? And then here we can look at corn production for the Corn Belt, and what we see is take this to the extreme. We are paying the price in our areas that have the highest grain yields. That's where it's even in places where we have the best crop production is not immune at all. In fact, it's one of the most susceptible to this steady erosion of performance of our weed management systems. All right, last slide here. So this this is just a snapshot. It showed just work of what we've been doing, but it interfaces what builds on well with what Jeff was showing with Monsi's work, these idea of multiple stressors, how that impacts the crop and other work. But it's a really nice snapshot because these are field experiments and there are lots of environments. So it's for somebody who goes to a lot of work to have 4 site years. It is so fun to work with something where we have 1,000 environments, and I think it's informative. The key is we're limited on what questions we can frame, but if we frame the right questions, we can really have a nice job of getting a sense of an answer. So the race is on. I echo some of the comments early yesterday that while it might be outside of what this group can do, the whole idea of mitigating climate change is huge. That can't go away, but then we have to adapt to the rest of it. And my argument would be that weeds are adapting. They'll adapt, and whether it's climate change, but also management, and it should be incentive to how do we slow that adaptation? How do we prolong the usefulness, at least in terms of managing them? I think we make it less easy for them, make it more difficult. And so having not these simplified systems, but more diverse management systems. And so yeah, that's it. That's the end of it. Appreciate it. Thanks for the attention.
Questions from Marty?
Yeah, Shelby.
This is Shelby Fleischer. So yeah, I'd like to talk in the idea of increasing variation when we deal with insects. We look at dose response curves. That's the first thing we pay attention to, and kind of a precursor to say, okay, resistance is on the way. What surprised me is as I watched genetically modified crops come along, so you've got your herbicide tolerant crops, but right at the same time, we had the BT GMOs come into come into play. And there was a dramatic difference in how it was dealt with. When I used to teach about this, I would say that the deployment of BT GMO crops was the first and only example of resistance management plans being required by government agencies prior to their release, both in agriculture and in medicine. And those tactics still exist to their effectiveness we can discuss and so forth. But why in the world did that happen where, if you release a BT GMO thing, even today, you have to have a resistance management plan approved by EPA, reevaluated every 5 years. And yet the herbicide tolerance is like ignored. I don't see how you're going to get ahead of this unless you are proactive to require a resistance management plan before you have
Yeah.
this in place. So why did it happen with BT crops and not with herbicide tolerance?
Yeah, well, so remember Mike, I don't know, yesterday I said something that's I'm not that's why I don't like to, I'm not social scientist and throw my hands up because it's just outside, but it's a great question. It's a great question. Part of it, well, I can't talk on what was required federally from Monsanto at the time, but I've got another version. I don't have a slide in here, but the launch of it, I mean, it was from the manufacturer, it was just use glyphosate, only glyphosate. And, it was really poorly, the messaging was really poor. And you can have plenty of other folks from academia and government, say, hey, time out, wait a second, that's might not be the best idea. I mean, I remember as a grad student, one of the other grad students working in Roundup Ready, he's like, oh, it's impossible. Like, never have glyphosate resistance. And I'm like, really? I explain this to me again? And
So I
Yeah.
asked this
We just have
question.
this is not IBM.
right.
This blew the concept of IBM out of the water, right? Because all of a sudden, the silver bullet,
Yeah,
there would never be resistance to, was had arrived.
right.
So I've tried to ask this question numerous times. Now that I'm retired, I can speak out for what it's worth. I've heard three major themes that I come across, and I don't know if any of them are true. But one that makes the most sense is that the BT crops were targeted at, they claim to be just one species or two species. Whereas if you try and do this for glyphosate resistance, you're aiming at a community. So there was no concept of how you might do it. That was one. Another was that EPA claimed that this is like hall talk. I'm waving my hands at it. But EPA claimed that they had a regulatory authority. And to do that, you have to have a potentially harmed, someone that's harmed or some community that's harmed. And if you get BT resistance, there's a community of organic growers that are presumably harmed because they spray BTs. Now, they were talking about European corn borer. You don't really spray BT for European family, but they claimed they had a potentially harmed audience. Whereas with herbicide tolerant crops, if you lose the herbicide, the harmed community would be the companies that make the herbicide. I don't know, but that was a second theme. And the third theme, and I'm really waving my hands here, this may not be fair to talk to lead scientists about, but as this is happening, which is the 1990s, in the world of the Entomological Society of America and the world of entomology, we'd already been clobbered. I mean, starting in 1950, by 1950 to 1970, we are hundreds of species and thousands of populations, total resistance. The idea that the insect can't evolve resistance, and people, I go back to the day where I remember people saying that, but that had been like trash. And so models were in place, experiments were in place to say, look, if you go down this track, you're going to lose it in 3 to 5 years. And that was the whole society, including the entomologists that worked for the companies, we're all on board with this idea. Whereas weed scientists, the notice comes years later. And
Well,
so
I mean, I was there. It was a small, no, there's plenty of weed science community of like, this is not a good idea. But, it's, free market, capitalism and there was definitely, a company, there was company push to, and so that's what we're at now. We've had a period of, well, let's just pull some broad, non-selective herbicide off the shelf, introduce resistance into the crop and use a herbicide, some old chemistry like Camba or 2,4-D. Those that there's I'd be careful like classifying like, hey, weed science and bozos.
So we can throw that one away.
But seriously, we do need to move on. Just suffice it to say, every time a company has said there will not be resistance to this product, they were wrong. Regardless of what the target audience was, so target organism was.